Inverted Perovskite-Organic Tandem solar cell achieves 23.07% efficiency via metal ion doped absorber. A group of scientists in Korea has a hot air technique instead of atomic layer deposition to fabricate a perovskite absorber that reportedly shows a higher film quality. They applied this film in a perovskite-organic tandem solar cell, which exhibited low open circuit voltage losses and high efficiency levels. Researchers led by the Tandem National University in South Korea have designed a two-terminal monolithic perovskite-organic tandem solar cell based on a metal ion doped perovskite absorber and a NIP layout. In NIP or inverted architecture, the solar cell is illuminated through the electron transport layer, ETL, side. In the PIN structure, it is illuminated through the hole transport layer, HTL, surface. We demonstrated a new hot air method for monolithic tandem solar cells and its stabilization through metal ions doping, the research's lead author, Salwana S. Mali, told PV Magazine, adding that the proposed manufacturing process is free from atomic layer deposition, ALD, and sputtered techniques, which are commonly used for the deposition of a protective interconnecting layer in tandem devices. Except for thermally evaporated molybdenum trioxide, Mu3, and silver, Ag, all layers were fabricated in ambient air conditions. Unlike the conventional antisolvents method, the hot air technique reportedly facilitates the formation of a highly uniform intermediate complex due to partial evaporation of solvent, thus resulting in a higher perovskite film quality. We blow a 150 C hot air gun directly over the spinning substrate, the scientists explained. The top perovskite cell was built with a substrate made of fluorine-doped tin oxide, FTO, a mesoscopic electron transfer layer, ETL, the perovskite absorber, a hole transport layer, HTL, based on 3,4,9,10 tetra-N-alkoxycarbonyl paralenes, PTAC, a top donor material known as PBDBT, a buffer layer made of molybdenum trioxide, Mu3, and a silver, Ag, metal contact. The bottom organic cell was made with a substrate relying on ETO and glass, a window layer of zinc oxide, ISNO, and PDI derivative, PDIN, a phenyl C61 butyric acid methyl ester, PCBM, layer, a Mu3 buffer layer, and an Ag metal contact. Tested under standard illumination conditions, the Champion tandem device built with this architecture achieved a power conversion efficiency of 23.07%, an open circuit voltage of 2.110 V, a short circuit current density of 13.65 mAh2, and a fill factor of 80.1%. The device was also able to retain over 90% of the initial efficiency over 600 hours at maximum power tracking under continuous illumination. Our approach demonstrates solution-processed absorbers with organic cation passivation to reduce open circuit voltage loss down to 0.025 V, which is the lowest reported to date, the scientists stated. This structure also demonstrates the merits of limited recombination and high reproducibility. The novel cell design was introduced in the paper All-in-Organic Halide Perovskites for Air-Processed and IP Monolithic Perovskite/Organic Hybrid Tandem Solar Cells Exceeding 23% Efficiency, published in Energy and Environmental Science.